today in my class, I mean, it could be a little different in other teachers' classes, but we did lesson 3, and we also did our first quiz. We'll talk about quiz corrections and that process in a second. But today we didn't even finish the whole lesson, so one of the learning targets we weren't really able to do, which is to look at the equation and the graph. We can do that right now. But we definitely practice writing the equation. We just learned how they're set up today. And then interpreting it and how it represents exponential. So if you've ever heard that phrase, exponential growth, or that something's growing exponentially, you guys need to look at up here stuff like it basically means that something's growing at a really fast rate. So think about like when COVID happened, that was an exponential growth pattern because people were infecting other people without like even knowing that they were sick, right? Like that was a big issue. So you could say each person that had it was infecting like 3 other people, for example. And then those 3 other people are infecting 3 other people, or probably more, but like just simplifying it. That makes a graph that maybe starts out at a slow increase and makes it like a really steep curve, similar to this if we're talking about exponential growth. And you kind of saw that in the like genie in a bottle lesson, the one that it doubled every day. That graph had more of like a curve to it. That's why back then you might have remembered hearing people say, oh, flatten the curve, wear your mask, wash your hands, social distance, blah, 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 flatten the curve. This is the curve that they were talking about, the exponential function. By doing those things, you were limiting spread of germs, right? So you were lessening the amount of people getting infected. So really cool stuff. That's what a graph would look like if it's exponentially growing. Notice that it's not a straight line anymore. And features of the graph, you can connect the equation to it. We just learned the equation today though. So what's the equation for a linear function? Better?
Y equals mx plus b.
Okay, good. The way that you're able to recall that, you need to start being able to recall that exponential functions. And there's some variations of how you can write this, but exponential functions are y equals a times b to the t power. What does a represent? The initial value of whatever it is we're talking about. If we're talking about like number of people that have a cold, patient 0 would have been like the first patient, right? I don't know, but that's what we're starting with, is always what's being multiplied by a different number that has an exponent attached. That number that you are multiplying by, we call it the common factor. So like if it's doubling, what's our common factor? 2. If it's tripling, what's our common factor? If it says it's multiplying by 10 each hour, what's our common factor? So that's what will be attached to an exponent. The exponent represents time. So if they're saying that time is hours, seconds, minutes, days, whatever they're saying is going to be the exponent on the common factor. All right, and that's basically what we learned today. We also talked a bit about some of the exponent rules. So that was at the top of your notes right here, if you need to refer to them. We tried to understand some of them a bit better, but especially the 0 exponent rule is really relevant in this unit because whenever the exponent is 0, what does it equal? 1, good. Which, when you do that, say that I put this as a 0. Listen, friends. say I put b to the power of 0, b to the power of 0 is 1, that just gives me a, which is my initial amount. So that's why we said like our 0 is your initial amount, right? That's where it comes from. So it's all like coming together, just like a little piece at a time. So if you're confused about any of it, tell me, I'll try to explain it a different way, but it's so important that you get like these little details. The minimum requirement today is that you get 80% or higher on this practice. There's some of you that I will be pulling to either take the quiz from earlier, because you were in my 3rd hour, or something else. Some of you are in my stride on Monday, so I want to make sure you'll be able to participate in some quiz corrections that we're doing. So yeah, I'm going to make you take the quiz right now. But this is what you're working on otherwise. If you're finished with it already, I recommend those IXL skills, get the extra credit. What else could you do? Other homework that you're missing. Some of you are still missing like the syllabus quiz, like silly things. Just get it done. I'm gonna help you need help as you go. Okay, so we're in the last 20 minutes and I do want to go over number 2 on lesson 3 because we didn't quite see an example like that yet. I didn't know it had percents already on your homework, so let's talk about that. Today you just for the first time saw me define an exponential function. I defined it as this. Hold on. All right, exponential functions have this type of setup that we talked about. However, when it says that it's growing or decaying at a certain percentage, it might be better to use this setup, which is equivalent, but it allows for the percent. So the way that it works, it's A is still going to be your initial amount. It's going to be multiplied by 1 plus or minus, depending on if it's increasing or decreasing. But it's going to be added to the growth rate as a decimal. So like the percentage, but as a decimal. And then the exponent will still be fine. So it's just another way to talk about your common factor. So what's my initial amount in this situation? The 12,000. Hold on. 12,000 is my initial amount. It's going to be multiplied by 1 plus because it's increasing at a rate of 6%, with 6% as the decimal. That would be 60%. Okay, now that's less than 6%. 0.06 is equivalent to 6%. The way you could do that easily is do 6% divided by 100%, because you know, like, and yeah, the same thing on top and bottom, it'll cancel. The percents will cancel, and it'll give you the correct decimal every time. Do that. So whatever percentage divided by 100% will give you the decimal. So it's going to be 1 plus 0.06 to the t power. So what time frame do they want the answer for? I know it's hard to see the way I zoomed in, but 4. So this I can, since they're all numbers, I can put in my calculator exactly the way it is. Otherwise, you have to do like order of operations, but I prefer you just type it all in at once. That's 12,000 plus 1 or times 1 plus 0.06 to the 4th power. Like that. That's what we plugged into the formula. Then we get this amount, which we're talking about how much it costs. So what should we round to? We're talking about dollar. How many decimal spaces does a dollar have? So I should round to 2 decimal spots. That might be why some people got it wrong. I mean, I'd be surprised if you got the setup correct off of that, so I didn't necessarily tell you. But since we're talking about money, you want to round to where it looks like money. So look to the right, if that's a 3, we're gonna keep where I underlined the same. And what you're gonna type in is 15. Put it over here. 15149.72. I would type it just like that. I would not put commas unless they tell me, and I would round to where it looks like money. There's a couple variations of the answer. It'll automatically grade as right, but if it has like the dollar sign on the outside, don't put it in again. Just tell me if you got this, let it mark it wrong, then I'll just apply the point. All right, questions on that one? Questions on any others? From any purpose, anything in general, any area general? Question 8 on this one. The one that starts with in 1985. So in 1985, there were 285 cell phone subscribers in Mayville. The number of subscribers increased by 75% per year after. And how many subscribers were there in 2008? So same setup, we're talking about an exponential function because we're using that it increased by a percentage each year. Since we're talking about the percentage, we're going to use this setup of a exponential function. And in order to do that, you need to know what the initial amount is. So what's the initial amount? Okay, good. In parentheses, it's going to be 1 plus or minus. Is it growing or decaying? Growing, so I'm gonna put plus. This percentage as a decimal with 75% as a decimal. 0.75. To the t power. What time frame are we looking at? Great, table 6, keep it down, please. Where the time frame is 23 years, that's correct. So you're not plugging in 2008. You're not. I mean, I guess you could do 2008 minus 1985 in that exponent, but the way you type it in your calculator, it'd probably just be easier to type in the 28 power. That's wait, are you sure it's 28? 23 is actually what it is. Oh, okay, well, I wrote down. Okay, now it looks better. Gonna try this calculator. Whatever calculator you use. I prefer it be one that you can type everything in at once. And we're going to the 3rd. All right, that's how you would type it in using this calculator. And that's what it equals. Now, can I have a decimal of a person? No. The way that we're going to answer this is we're not going to, because you can't have a decimal of a person. If it were a number high enough to where we would round up, we would still just keep whatever it says here. Like, even if we're supposed to round up based on the decimal, don't. because the data doesn't support like a full another person. So we're just gonna type in 110 845 988. That's how many. See if that's correct. Hold on.
I think that's the.
Okay, it should accept it without the commas. Let me make sure it does. Because I actually prefer you don't put commas unless it tells you to. So yeah, both with the comma and without are correct, but you should definitely not have a decimal when we're talking about people or other things that can't be decimals. All right, any other questions?